this video, we are going to look at how to differentiate y is equal to x squared minus 3 all squared. So I've got method 1. Method 1. In this method, we are going to expand, because y is equal to x squared minus 3 all squared is equal to, we square this, that's x squared, it becomes x squared becomes x to the fourth, and then x squared times minus 3, we get minus 3x squared times 2, so that it becomes minus 6x squared. Then minus 3 times minus 3 is positive 9. And then now it's ready for differentiation. Then we say dy over dx is equal to 4 times 1, which is the coefficient of x to the fourth. It is 4x, that's fourth power minus 1, minus 2 times minus 6, so it's 2 multiplied by 6x, and then 2 minus 1, like that. And differentiation of a constant is 0, plus 0. This then will give us 4x to the third minus 12x, just like that, because 2 minus 1 is 1. This is the first method. The second method, we can say let y be equal to u squared, and u is equal to x squared minus 3. So this expression is u, and we square it, right? U into square, because y is equal to u squared, and then u is represented by that. And now we can differentiate these separately, meaning that we will end up having dy du is equal to, this one is 2u, while this one is du over dx is equal to 2 times that's 2x, right? That's 2 minus 1, right? If you want, this is also 2 minus 1, meaning this will give us 2u, while this one is 2x, because derivative of a negative of a constant is 0. Having done that, now we can go back, and you can see that dy over du, over dx is equal to dy over du multiplied by du, let this be clear, du over dx. If you can check this, and that will get cancelled, so that we end up with the dy over dx. Then we substitute with what we have right here. For dy over du is this one, which is 2u multiplied by du over dx is 2x. That's 2x. And this will ultimately give us 2x u. But u, we said, is this one. So it's going to become 2x, oh sorry, there's a mistake here. There's a mistake on this. 2 times 2 is 4 x u, right? Meaning that we end up with 4x, and then u is this x squared minus 3. Right. This and this one, they are exactly the same, because if you check 4x times that, it will give us 4x to the third, while 4x times minus 3 is minus 12x, which is identical to this one. This method, the second method, is of advantage when, say, you are given an expression which is like this. That's where it is most important. Let's say this time around you are to differentiate y is equal to x to the fourth minus 4x to the power 8, like that. When it is like that, obviously when you try to multiply this 8 times, it's a tedious exercise. So we end up saying, let u be equal to x to the fourth minus 4x, right? So that y is equal to u to the eighth. When the situation is like this, then we can start by differentiating that one at the top, which is du over dx. It will be 4x, that's 4 minus 1, which is 3, minus 1 times minus that one is 4x, 1 minus 1, right? So it's 1 minus 1, right? And so that this becomes 4x to the third minus 4, right? And when we come to the second, we have dy over du. This will give us 8u to the power 8 minus 1, which obviously is 8u to the power 7. Now, it therefore means, therefore, dy over dx is dy over du multiplied by du over dx. Then we multiply the two. This will give us dy over du is this one, which is 8u to the power 7 multiplied by, it's better to open the bracket, and then we put 4x to the third minus 4. Right. Since u is x to the power 4 minus 4x, it therefore means our final answer is going to be, let's start with 8, then we write this one, that's 4x to the third minus 4, and for the u, let's put it at the end, which is this one to be x to the power 4 minus 4x to the power of 7. This becomes our final answer. That becomes our final answer. So that is when we are using the product rule. Thank you.